In physics, we describe energy as the ability to do something or be doing something. You're probably familiar with the terms kinetic and potential energy. Now, on the most basic level, these two energies are not different from each other. They just represent different ways in which the energy of the system is represented. So for kinetic energy, our object is moving. And that's some sort of a doing. There's a doing that's happening, and we can see the object is moving and has this energy about it. Now, potential, you've probably used that to describe what the Earth is doing to the object, or the gravitational energy. Now, potential really just indicates that the energy is stored. That's really the more important way to think about potential. So it's what's stored. Now, we can have energy stored in the motion or stored in the location. So for gravitational energy, it was all about the position of an object. Now, we'll also can have potential energy as being a energy stored in a spring or something that's elastic. So it's important for us to move beyond our elementary understanding of energy and begin to see energy as a quantity that can be described for a system based on its motion or where it might be located relative to other objects. I think of the potential energy, the gravitational energy, and the elastic or spring energy is energy that can do something rather than is doing something. Let's get a little more specific and move beyond just potential, and let's define it as gravitational energy. Yes, it is potential because it could possibly change the motion of the object, but gravitational energy is more specific in describing how the energy is stored in the system. I want to focus on this idea that energy is the most important part of this phrase, and so I'm going to write E for energy, and then I'm going to use a subscript like I usually do, and let the little g represent that it's a gravitational energy, so it's the energy stored in the position of the object. Now, as we saw from the energy skate park, as you placed your skater at a higher position, there was a resulting difference in how fast the skater was moving at the bottom of the ramp there as she made her way through the bottom of the loop. So we see this translation of something is stored here, and whatever was stored here is converted there to some sort of movement or motion, and we'll get to that piece in just a second. So let's look more at this energy stored. So at a particular height, our energy stored depends on the mass of the object, so the mass of the skater, the gravitational field of the planet, and the height. Now, as you manipulated the height of your skater, you should have seen the pie chart grow bigger and bigger as you manipulated the gravitational constant of the skate world from low to high. You would have seen the gravitational energy change, that pie chart change, and if you change the mass of the skater, you'll also see the pie chart change there too. Now, since the skate park is only using gravitational energy as the storage mode, the graph is simply labeled potential. But just understand that there are different forms in which energy is considered potential: gravitational potential, electric potential, elastic potential, chemical potential are all forms of stored energy. Notice the pie chart here drawn for the energy stored in the skater system at that highest point. Notice that it is all blue. This all blue represents that it must all be in this category here that is the potential energy. Now, because this simulation is only using potential energy to describe gravitational energy, the extra word wasn't used, but this really is gravitational energy of the skater. Now, as we watch the simulation, we see the skater reach the bottom of the ramp. So at that point, there is no blue in our bar chart over here, and the pie chart has changed. So let's look at that. Now when we see the skater at the bottom, we see that there is no blue for the potential energy. Remember, that was our gravitational energy. So there's no potential energy, no gravitational potential energy. But notice the whole pie, as well as the whole bar chart over here, is now green. And that represents our kinetic energy. Now, kinetic is a word that means motion. And also notice that when you turn the speedometer on, that the speed of our skater is the greatest at this bottom position. So that tells me that it's moving the fastest at this point, and that all of the energy of the system, because the whole pie is green, all of the energy is stored in the motion of the object at that point. So for our kinetic energy, I will write it as an E sub K. Again, I want to emphasize that it is energy, so I'm going to use an E. Then I'm going to use the subscript K to represent that it is in the form or the way it's being used right now, or what's happening is that it's moving, it's in motion. So because the energy is now stored in the motion of the object, and you may be familiar with the kinetic energy equation from physical science in middle school, but it's 1/2 mv squared. You also may notice that if you put your skater at the lowest point of the U, the skater won't go anywhere. The skater doesn't have any energy at that point. In order for the skater to move, energy has to be transferred to the skater, and in this case, with our skate park, the gravitational energy that is present when we are above the Earth's surface is what fuels the ability for this skater to move back and forth. Now, once she's moving very fast through the bottom, she has energy, and as she goes up the other side, her kinetic energy will decrease because she's slowing down, but we'll see the gravitational energy is increasing because we'll see that the person gets higher and higher above the surface of the earth. So you may notice that at this point there is nearly equal amounts of both the blue energy, which is the gravitational potential energy, and the green energy, which is our kinetic energy. Now notice that the total energy of the system remains constant. And this is an important concept, that the total energy of our system is constant.